This slide provides a fundamentals information with respect to the operating point around peak power. At the peak power, they have two quantities. One is called peak power level and peak power voltage. The nature of MPT has a nonlinear control that requires the sourcing voltage to fluctuate, such as array voltage ripple that superimpose on the operating point. This fluctuation of voltage causing the fluctuation in power, and as a result, every cycle of solar array voltage AC swing will cause the power to touch the peaks twice. In other words, it produces frequency Doppler effects. The power ripple or AC information superimposed on power signal having the frequency twice as much of the solar array voltage ripple. In this manner, it is equivalent to the effective 90-degree phase shift of the power information. Since when this information is processed to the exclusive OR gate, it will end up with the same result that shown in the previous chart, that V sub x will be 1/2 of operating bias that used for integration, which is this V sub x. And in this fashion, the integrator or the last state of the maximum power tracking processing circuit able to reach its steady state value corresponding to peak power voltage called VMP. In other words, the VSP is always proportional to or corresponding to the VMP, the actual peak power voltage. This slide provides information of two signals relationship. One signal is a power signal, and second signal is a sourcing signal. Power signal shown in purple color. Fortunately, the I-bus signal or the total source current signal feeding sourcing out from the C-pole converter is shown in red curves, have the same phase information as the power ripple, which is belonging to the AC ripple superimposed on the total sourcing power of on Siri connected power sources. The sourcing voltage in blue, as we can inspect from this plot on the upper left hand corner, have the in-phase relationship between the power signal and the sourcing voltage signal. This corresponding to the power operating point on the left side of peak power point, such as this point, where the power variation and the sourcing variation are in phase to each other. On the other hand, when the operating point of sourcing voltage and total sourcing power in the located on the right side of peak power, the power signal and the sourcing voltage ripple totally out of phase or 180 degree phase shift with respect to these two signals. These corresponding to the operating point on this on the right side of peak power point. Finally, the plot on the right side showing the total sourcing power that have a frequency double effects at the same time. The total sourcing bus current I bus have the AC ripple that have a phase shift with respect to the sourcing voltage of 90 degrees. This signifying that the system already reached peak power point. This slide showing the block diagram of battery dominant power architecture with uniform voltage distribution, maximum power tracking control. In this architecture, power source number 1, number 2 and power source number 3 are connected in series, and their total serial voltage V1 with respect to the ground are basically become a common sourcing voltage to the high voltage load. At the same time, each power source is distributed connect with the inputs of each C-pole converter, which is Siri input parallel output converters. Converter number 1, converter number 2 and converter number 3 are Siri connected converter. Their outputs are connected in parallel across the battery voltage called V-bus. The total sourcing current out of these three C-pole converters I bus, sourcing the current to both battery and the system load. At the same time, parts of the I bus go into battery, we call battery charging current IBAT, which provide the feedback to the system controller so that the battery charging current is able to be regulated to the target command. In this particular architecture of battery dominated bus using C-pole converter, the system controller needs 6 feedback variables. These are serial input voltage V1, V2, V3 and battery charging current IBAT, total sourcing bus current I-bus and bus voltage, which is the battery voltage V-bus. The system controller then producing distributed control voltage VC1, VC2 and VC3 respectively, controlling the isolated control converter number 1, number 2 and isolated control converter number 3. To properly regulate the power flow in such a way that the voltage across each power converter or across each power source are equals or uniformly distributed. That means V1 minus V2 equal to V2 minus V3 and equal to V3. In this manner, the system able to provide uniform voltage distribution across these three power sources at all times.